Hi everyone, welcome to Physics with Ben. This is a continuation on the video series on prediction of 2005 Waec Physics Alternative A. I have already done video on question number 1, mechanics. You can find the video link in the description on this video you are currently watching. So in today's video, I want to run the experiment for optics. Optics is question number 2. So based on the apparatus given, I want to repeat this. This is a disclaimer. Whatever you are seeing in this video is not your real Waec question. On the D-Day, you're gonna have something close to this, something close to this, not exactly as this. Again, this guide will also give you an overview of what you would be expecting on the D-Day. So I do not aid and abet examination malpractice on my channel. Stay away from examination malpractice. Watch my videos, and I want to assure you at the end you will come out with a clean grade, A1 or B, or at least a C. Okay, without wasting more time, let us go straight to the business of the day. Based on the information given by the chief examiners, we are required to make use of a plane mirror. We are required to make use of the rectangular glass block. And these are the thumb pins and then optical pins. So we just need 4 of the thumb pins to hold the papers, and then the optical pins. So and then we need materials like this to help us run the experiment. Every experiment has a reference in the textbook or the past questions. For this year's optics, I want to show you where you can find it in the textbook. This is the past question that I am using, and look at this here. This is the arrangement, and then this is for the year 2010. That's the year you can find this experiment. And then if you open to the year 2020, it's the same experiment. So without wasting more time, let us run the experiment. I have just projected the instruction beside the video you are watching right now, and look at it, and then we'll run the experiment. First things first, as I said earlier, you have to personalize your traces. So I'm going to write experiment 1, and then I'll write my candidate name, Okuma Benjamin. So your candidate name, your center number, your candidate number, something here, so that if the traces are misplaced, they can mistakenly misplaced, they can still be traced back to you. Examiners are not careless. Don't be afraid. Your traces will not be misplaced. Thank you. So next thing is the outline. You put your hand like this. You draw the outline. Don't forget that is instruction number I. Instruction number I. Draw the outline. So this is the outline. Good. You take it up, put it aside. They say the outline should be A, B, C, D. So this is your A, and this is your B. Now on this side that we are going to place the mirror, because we are going to place the mirror on the other side, you definitely this is the symbol for mirror in physics. This is the other side. Good. So this implies we'll definitely put the mirror here as we proceed. So instruction number 2, they say we should remove the block. We have removed the block and we have done that. So we should draw the so this is A, B, and this is C, and D. The next line of action here that say we should measure the weight of the block, meaning from here to here. So the weight of the block, the width of the block, this is from this point to this point. That is 6.1.2. 6.2. So 6.2 cm is the weight of this block, and the weight W is equal to that. It's constant throughout the experiment. So next thing they ask us to do is they ask us to draw a normal ON to DC. ON to DC at the point about 1/4 the length of the DC. So we are going to draw a normal here. This is supposed to be 1/4. Don't forget this is 10. So we'll have 2, 4, 6, 8, 10. So we go with let's go with 2. Yeah, let's go with 2. So we draw our normal here, and while you draw your normal, your normal needs to be perpendicular to the surface. So you have to put your protractor to be sure of that. So this is where you put your ruler. So you join these two lines, and that is your normal, and this is your NO. The next thing they ask us to do is to incident ray. Our incident ray is supposed to be 30 degrees to the normal. So come back here and write this formation for me. I is equals to 10 degrees and W is equals to 6.2 cm. So how do you draw this? Remember, this is from here to here is 90. So it is calibrated toward 10 degrees. So if you place it like this, watch me, this line needs to be aligned with this. So you place it like this. Good. You now read this way. This is 10. Right here at this 80 mark, put a dot here. Take it away. And then help me join this line to meet this. Now take note, your incident angle is always taking reference to the normal. So from this point to this point. Don't forget I told you your pencil must be very, very sharp, which is part of the precaution. Good. And then indicate the arrow to be going like this. And this is your incident angle, your eye. The next thing the examiners ask us to do here is to replace the block and mount the plane mirror at the back. So we have to replace the block where it was before. Replace it in its outline. Then remember, we did something like this, it means the mirror. So this is the side here, and this is the reflecting side. So you have to place your mirror. Good. Next up, they ask us to place 2 optical pins, 2 incident optical pins. So this is first one. Now take note, your 2 incident optical pins must be 2 cm apart. 4 cm apart. So you place one here, and they must be erect. So these are part of the precautions. So This is 4 cm in, and then the next one is right here. Good. So the next thing the examiners ask us is to look through side DC. If you watch very closely, look at this place here. Look at this place. Good. You see these pins here? You are to put this particular pin in line with those pins, with the pin you are seeing inside the screen. Good. And then the second pin, again, somewhere here. That is what it means. And this pin becomes your pin 3, and the next pin becomes what? Your pin 4. So pin 3 and pin 4, they don't need to be 4 cm apart. Only pin 1 and pin 2 need to be what? 4 cm apart. So this is what you do. This is how you do it. You have to bend down and look. Yeah, that is pin 3, and this is pin 4. Yeah. The hole that you are not using, you have to cancel the hole. So you have to remove this pin and label it pin 1. Remove this and label it pin 2. Remove this and label it pin 3. Remove this and label it pin 4. This hole is not good hole, so take note. So next up, you have to take this arrangement aside, and then based on the instruction here, you are to join these 2 pins to reach surface DC. The line should not pass beside the holes, but in the middle of the hole, something like this. They should pass in the middle like this. So you join these 2 lines like this. Good. And then you draw a new normal. You draw a new normal. Good. Something like that. You draw a new normal. So this is your I, and this becomes your, so this particular line now becomes your E, your angle of emergence. Look at it here. Look at it here. And this line is supposed, the arrow is supposed to face this side. So next up, you need to join this line. You need to join this line. Good. And you also need to join this line. And so this arrow goes here, and this arrow comes up here, and in the middle this is perpendicular to this surface. So based on these instructions here, we are to measure this angle here, and this angle happens to be our theta, meaning you have to include here theta is equals to that. We are also advised to measure E. How do you measure angle E? Very simple. Your E is to be measured. You also have to measure the distance between these 2 normals. This is your N prime. Your N prime O prime, and this is your N what? O. So the distance between these two numbers, you have to measure it. So this is 1.5, 1.55. This is 1.5. So this is 1.5, 1.6. So D, let me just put it here. Your D is 1. Your D is 1.6 centimeter. So let's measure our E. How do you measure your E? There's a line here, and this is the middle. And then you place your protractor like this, and this line goes here. Good. So this is 10. Observe. Each line is 1 degree. So this is 10. This is 10, 11, and 12. So E is 12 degrees. Good. So we record 12 degrees. What is theta? Theta is also very simple to find. You can use this point to put it here. So right here, from this point to the middle here, we can find our theta, which is this line here. Look at this line here. Take my cross code. So from here to here is our theta. So let's count. So this is 10, and this is 20. Theta is 20 degrees. Yes, theta is 20 degrees. So record theta is equals to 20 degrees. So we are done with the first set of the experiment. You remove this and repeat the procedure. You remove this and repeat the procedure. So this diagram looks like this. So what we have just done, you have to repeat it for more other values of theta equals to 20, 30, 40, and 50. Don't forget they asked us to evaluate M. They also asked us to evaluate M, add to the list. So they asked us to evaluate M. M is equals to what? M is equals to sine E in each case. So they also asked us to evaluate N. N is equals to what? Cos bracket theta over 2. So I'm going to run the remaining values so that I will discover the trend in the experiment, and then we are going to plot the graph. By the way, based on this first one, this is how our table of values will look like. So your table of values will look like this. The first one, this is where you lift and form your table of values. You have I, so you record your I/degrees. You draw a line down. The next one is a constant, which is width. All constants are supposed to be recorded on top of the table of values. So that is 6.2 cm. So this is the reason why you don't need to collect values on the internet. Another candidate for another center is using this glass and the weight is not 6.2 cm and you collect it, you just distort your calculations. So the next one is theta. So you record theta / degrees. So the next one is E. You record E / degrees. The next one is D. D will also vary. D / cm. The next one is M. And your M is what? Your M is equals to sine E. I will verify the unit later. Not too sure of it right now. You put the straight line again. Then the last one is N. Your N is what? Your N is equals to cos bracket theta over 2. Bracket close. I will verify the unit later / the unit. So based on this information, we have 10.00. Don't just write 10. 10.00. Our theta is 20.00. Our E is 12.00. Our D is 1.60. Our M, so our M simply means sine E. Sine of this, sine 12, meaning sine 12. So you press sine 12, you find out the answer is let's try to 4dp. You have 0.2079 to 4 decimal places. Cos theta over 2, meaning 20 over 2 gives you 10. 20 over 2 gives you 10. So you just write cos 10. So cos 10 is 0.9848. Always write sine and cos whatever to 4 decimal places, the way it is in the 4-figure table. So you have to replicate this for how many other values? This is 10, 20.00, 30.00, 40.00, and then 50.00. This is how your table of values will look like. In both years, this is how the table of values will look like. So the whole of this is for this. Another one for the whole of this. That is the experiment. So we want to run the second value, and this is 1, this is 2, 3, 4, 5. We have to have 5 traces which will be attached to your answer booklet. So we want to run 20 now when I is 20. So this I will write experiment 2, candidate name Okuma Benjamin, or physics with Ben. We are through with that. So you place it again, you trace the outline. So the outline remains A, B, D, C. So our I, right on it, our I this time is 20 degrees. Our W, we did not change this. Our W is still 6.2 cm. So the next thing we have to do is to draw our normal again. Don't forget what we did the other time, so we'll repeat the same procedure again. This time I wish to shift a little bit, let me say 3 cm or 4 cm in. This is I want to shift 4 for this. I want to shift 4 cm inside. I'm not too okay the way this one was. It was tilted on one side, but there's no problem. Let's shift it 4 cm inside again. So this is my normal. I can draw it without the protractor right now. This is my normal. And then the next thing I have to do is this is my normal. This is N O. This time I have to use it. This is 20 degrees. I have to place my protractor like this. And this is 10, this is 20, this is 10, this is 20, and I put a dot here. I'll take it away. I will join this line back again. Good. Don't forget, this side is where you are going to put the plane mirror. So you have to do the sign of the back of the mirror here. Good. Next up, I don't need to go through the instruction again. Next up, I'll just place. One thing about this experiment is that the more you do it, the more accurate you become at it. So this is 1 cm, and this is 4 cm right here. The two incident optical pin must be 4 cm apart. We have just done that, and they must be erect. So the next thing is to replace the glass. Don't forget, this is your incident angle I. It must take reference to the normal, not to the block, and your arrows are facing this way. And this is your pin 1, and this is your pin 2. You have to replace this back again in the outline, and then place this mirror at the back here. What we did the other time, you do it again. You now come back and view it from side DC. If you view it from side DC, this is you see that this one appears here. You have to close one of your eyes, like you are aiming at a game, a hunter, right? So that's how you go about it. And then, good. The next thing is you take this away. We are through with that. You remove everything, and then you put this. This is your pin 2, pin 3, and this is your pin 4. You remove this, gently put it beside, and try to join this back again. Don't forget what we did the other time. Then you draw a new normal here again. Good. That's your new normal. Then don't forget, this ray is coming here. It's bent. That is, it refracts, right? Yeah. Perpendicular. This one has to be perpendicular to the number in. So you have to be careful how you go about it. Something like that. And then this one too has to be perpendicular to the number in. Good. Wow. Perfect. So right here is your theta, and then in the middle of the theta you divide this line into 2. Wow. Impressive. So this arrow goes in. Based on this diagram, this arrow comes here again, and this one out here, and then out here. Normally this was supposed to refract, but because of this mirror, there is the refracted ray is acting as a reflected ray, going in and coming out, something like that. So come back here. This is your E. This is your E, and from here to here is your D. So you can observe that our D have increased. Our D have increased to 2.5. So from this point is our small d, and our small d is equal to what? Is equal to 2. Yeah, exactly 2.5. 2.5. Let's put 50 cm. So let's check to see our E. This is our angle of emergence, E. Our angle of emergent E, this point will be at the 90 cm mark. So we place this point here, and then we read. This is a 10. This is 10. This is a 10. This is 21, 22. Our E is 22. So right, our E is 22 degrees. Next up, our theta. This point will be here, and then this line will be aligned here. Then this line is what we are using for theta. We are measuring theta. Let's take it closer. Our theta is between this line and this line. So this is 10, this is 20, 21, 22, 23, 23.5. 23.5. So our theta is equal to what? 23.5 degrees. So that's our theta. And then they ask us to evaluate M. Our M is sine E. They also ask us to evaluate N. Our N is cos theta over 2. So we transfer this information on the paper here. So we take this up. And we add it up to this, traces number 2. So we transfer the information on the table of values. So your table of values is generated from your traces. So you see that if your traces are wrong, then your table of values is also what? Wrong. So based on this, our W remain W and our D. Yeah, this column for D, I thought this was not here. So our theta is what? Our theta is 23.50. So the distance between the two numbers, D 2.50, we got 2.50, sine E, sine E meaning sine 22, good. So we record to follow this mark places 0.3746. So next is N, which is cos theta over 2. So 23.5 divided by 2, 23.5 divided by 2. That gives us 11.75. So cos 11.75 gives us 0.9790. So repeat for 30, 40, and 50. So as usual, We are going to draw the outlines again. We take it out. Now the procedure is in my head, and then this is your A, and this is your B, this is your D, and this is your C. Don't forget to always write the numbers of experiment. This is experiment 3, candidate name Okuma Benjamin. Yeah, candidate number, and so on and so forth. Okay, the next thing, we have to put the sign of the mirror here, because we are definitely going to bring in our mirror here. So why experimenting this particular one? I want to use this one as a standard all through. I don't like the way this particular ray diagram is appearing. Yeah, it's not appearing perfectly as the one here. So if you want to get this, you follow me. So this looks very close to what is here. So from D to the first number is 4 cm. So we are going to replicate that, and we'll maintain it. So this is from here, from D to 4, we draw our first number, and our number needs to be perpendicular to the surface. Good. And so we write it, this is NO, this is NO. The next thing we have to do is we follow the instruction which are seen beside the screen. We have to measure 30 degrees. Okay, so you place your protractor like this, and then you measure. This is 10, this is 10, 20, and 30. 30, you put a dot here. Put a dot there, you take it away, and then you join this line to reach here. You join this line to reach here. Make it very long. Good. And this is your supposed incident ray, and then you put an arrow to indicate that the ray is going that way. Don't forget to write the details here. Your I is equals to 30 degrees. So the next thing to do is to insert 2 incident optical pin. So put 1 pin on this line. And don't forget, I said the optical pins must be 4 cm apart. So this is 1 to 4. So 4 cm is right here. Yeah. So the 2 pins are inserted. So this is pin 1, this is pin 2. So you right here, this is your pin 1, and this is your pin 2, and right here is your incident angle, which is 30 degrees. So the next thing is to replace the glass block back to its alignment, and then also place this back here, and then view it from here. Then you see what I'm doing. So got this. Good. Got this. So this is what I'm talking about. You see, the optical pins are on a straight line. So you see that when you view this through the glass, good. So if you look at this, these are the two pins inside where I'm touching. There are two pins here. If you shift it, discover that this and this, they are in line with the pins. Good. They are in line with the pins. So this is what it means. Good. You see two pins here. You see two pins here. One is here and one is here. Good. So you fix these two pins outside here to make sure they're in line with the pins you are seeing inside. So that is what we do here. So the next thing is to remove this. And remove this as well. This is your pin 3. Remove this. This is your pin 4. Remove this. And then join this line here. Join this line here. And then draw a new normal here. And so this becomes your emergent angle. So the next thing is draw another. This line will be inclined to this. Something like that. Then this line. Something like this. Then here becomes your theta. So draw it. Yeah, it will not be too perfect, but this is what we have. Then you put an arrow this way, and then you measure as we were doing before. So we want to measure our E. So you put this here, directly there, and then this to this becomes your E. So this is 10, 20, 30, 31. Our E is 31, so write E is 31 degrees. The next thing we measure our theta. Our theta is this line and this line. So this dot will be here. This line will be here, and this will be at the dot. So this was what we were doing the other time. Good. Something like this. So we'll have this line and this line. So let's count. So this is 10, 20, 30, 40 on the dot. So our theta is 40. So record theta is 40 degrees. Next up, we
have to measure our D. Our D is distance between these two normals here. Don't forget this is your N prime over O. Don't forget there's a point here called Q. I forgot to put that point initially, so this is your point called Q, and this is a point called Q. These traces are very, very important because they can give you your marks. So let's measure the distance between the two D. So this is a 4.1, 0.2, 0.3, 0.4, 4.4. So our D is a 4.44 cm. So we're going to transfer this result to the table of values. So our D, our theta is 40.00. Our E is 31.00. Our D is 4.40. So scientist 1 gave us this value, and so we record 0.5150 to 4 decimal places. So our cos is theta over 2. So 40 over 2 is 20. So cos 20 will give us this value, 0.9397. Yep. There is something I observe that I want to call our attention to it quickly. If you observe, this line is shifting to this side very well. So if we maintain this distance, this was 4 cm. From here to the first number was 4 cm. If we maintain this one on 40 and 50 degrees, we'll not be able to put a number here. Maybe the number will be at the boundary here. So what I suggest is that as we are getting bigger angles, we should be moving like the first one I did, which was this, which was from here to here. I was actually supposed to use like maybe 4 on the first one. So from here to here, 4. So as you are getting bigger, as the angle is increasing, you decrease the distance from D to the normal. So right now, I'll be going from 3. From D to the first number will be 3. Then the last one from D to the first number will be 2. So that this emergent ray here does not emerge somewhere here or here. That's the point I want to establish. Thank you. So this is what I was saying. If I did not shift this number backward, like from here to here is 3 cm. If I left it like 4 cm, this number would have been on this boundary now, and this experiment would have been useless. So the last value, which is 50, I'm going to shift my number to like 2 cm from here to the edge of D. That's what I mean. And then I discovered something again during the experiment. The easiest way to locate your point Q is when you are done drawing these two numbers, find the middle of these two numbers. That is, you place your ruler here, and from here to here is 6, meaning our D is 6. And so the middle of this line is at 3. So you put a dot here, and then you also trace that dot to this place, and then that will help you to join this line, and then join this line, then it's be in the center. So that's exactly what I'm saying. So this is the center. I discovered this during the experiment. You gain some skills while you perform the experiment. They are gaining during the experiment. So the arrow goes in here, the arrow comes out here, and the arrow busts out here, and right here is our E. And so here becomes our theta. You can now draw this line to meet it down here, and then the line is perpendicular to that, looking exactly like what is here. You see that this and this, there's no difference. So we want to measure our Q. Our Q now, our Q is this distance, this line and this line here. So this is 50. This is the inner one, 50, 51, 52, 53. 53 is our Q. 53 degrees. We want to measure E now. Put a dot here and let this dot be right here and this line to be here. So you place it this way. You see what I'm doing? So from this point to this line is your Q. So this is 10, 20, 30, 40. Yeah, this is our E. Our E is 40. So record 40 degrees. The next thing is our D. Our D is 6. So from this point to this point, D is 6.0 cm. So write 6.0 cm. So we transfer this to the table of values. So we are through the experiment, and this is the last part of it. Our table of values is also complete. So the next thing to do is to put everything back from where you picked them from, and so that you can still use them another day. This is very important. Put everything back where it belongs to. So there's something very important that I want to show you guys now. The next thing is to assemble this experiment in the order you have performed it. So if you can see very well, this is experiment 1, it will be at the bottom. Experiment 2, it will follow. Experiment 3, experiment 4, experiment 5. Yes, I took time to run them to the very end so that I will tell us something. So on the D-Day of your exam, the staple machine must be in your exam, and this is what you will do. At this point, you will, don't forget, let me just place them back again so that you see them very well. This is your experiment 1. This is your experiment 2. This is your experiment 3. This is your experiment number 4. This is your experiment number 5 with your name and initials written on it. So you put it together, and the invigilator or supervisor on the DD will come and then staple this. Good. You see this? And then this will be attached to your booklet. Will attach to your booklet. That is why I keep saying this experiment cannot be performed by group. It is an individual experiment. You can't run it as a group. So if you want to run optics now, begin to prepare for it. If you are a teacher, prepare your students strongly and individually on this experiment so that on the D-Day they will not be frustrated. So there's what I always do in my experiment. The next thing they ask us to do here is they ask us to, we have done all of this. They ask us to plot a graph of M on the vertical axis and N on the horizontal axis. A graph of M on the vertical axis and N on the horizontal axis. Now, in this Waec we are writing this year, Waec may not ask you to plot a graph of this against this. That is to say, this is on the y-axis and this is on the x-axis. On the D-Day, they may ask you to plot a graph of this against this, or this against this, or this against this. So open your mind to expect anything from Waec. Open your mind to expect anything from them. So that is what they ask us to do. Now let's look at the trend of the experiment. Between y and x, or m and n, if you observe, these values are increasing 0.2, 0.3, 0.5. This is 0.2, 0.4, 0.5, 0.6, 0.7. So the values of m are increasing down. And so the values of 9, let's look at it. The values of 9 are decreasing. This is 0.9.8, 9.7, 9.3, 8.9. So the values of 9 of n are decreasing. So this is increase, decrease. The trend for this experiment is increase, decrease. And anytime you have an increase, decrease trend in any experiment, this is how your graph must look like. So you can predict your graph from this. For the increase, decrease graphs, for the increase, decrease graph of m/degrees 0, 0, and what? And then n/degrees, your graph will look like this. Yes, increase, increase graph, they go like this. Decrease, decrease, increase, increase graph, they go like this, go like this. Why? Increase, decrease, or decrease, increase graph, they go like this. So this is the type of graph you are going to get when you plot the graph of m against n. M is increasing while n is decreasing. Very, very, very important. So next up, the examiners ask us to determine the slope and then evaluate Q is equals to 2SW. So and then state 2 precautions taken to ensure accurate results. There are 2 precautions you take here. One, you are making use of the protractor and the ruler. So what will you say? I avoided error due to parallax while taking reading on the protractor and on the ruler. That's number 1. Number 2, I ensured that the optical incidence pin were placed 4 cm apart. That's number 2. Number 3, you state that you ensure that you use a very sharp pencil. I've given you 3, but just choose 2 out of the 3. The next up, they ask us to, that is BI, explain the term refractive index and give a mathematical expression for it in terms of wavelengths. I will solve all of that and I'll attach to this video. Then state the condition necessary for total internal reflection to occur for a given pair of media. For total internal reflection to occur for a given pair of media, the angle of incidence from the optically more dense media must be greater than the critical angle. Number 2, light must be traveling from an optically more dense media to an optically less dense media. So to this, we have come to the end of this video. I wish you guys success in your exams. Distance yourself from examination malpractice, play your part and pray to God, and you will definitely succeed. I wish you guys straight A's, B's, and then at least a C. Expect video on electricity and you can find in the description videos on mechanics. Don't forget that mechanics has different version of questions. I have my version, and other YouTubers also have their version. I'm trying to, when I'm done with electricity, I can produce other version of mechanics. Be kind enough to share my content, subscribe to my channel, and click the notification bell for content like this. Thank you, and bye-bye.